So, welcome to the second and the last day for AI 900, which is session 5 in this workshop series. Next week, we will be having DP 900. That is one of the most desired certifications, but comparatively, the complexity is slightly difficult as well. It's not as simple as, AI or AZ. So, basically, because they have a lot of content. So, then the last 3 days are going to be packed with a lot of content. For now, all of you who have not filled this up, please fill up the attendance form. This is required for us to issue these certificates at the end of the event. So please do that. Before going on the break, we did create two models. One was a classification model and second was object detection. The classification model was able to identify animals and not animals. Obviously, we gave in that. And the second model that we created just before we went for the break was object detection. I hope for those of you, if this was getting created, if this was still in creation, you might have not tested it. So let me quickly go onto Wikimedia and get an image for a cyclist. I think this should be good. And in the quick test, I'm going to enter the URL and you can see the results that will come. So it says the cyclist, the probability is 98.4%. For those of you who want to test this, I have shared the image in the chat. And with this, we are done with the practicals. Coming back to the content that we have been, that we started yesterday that we have been discussing. Let's come back. We've got about 20, 25, 26 odd slides to cover. So here it's going to get a little theoretical. I'll try to finish this in the next 1 hour, 15 minutes or maximum 1.5 hours. And then we'll have the floor open for questions, queries, doubts. Depending upon if you ask me more questions, this might take all the way up to 3, but I'm expecting we'll be done by 3. And for any questions, practical doubts that you have, I'll stop the recording at 3, and then you can start asking me those questions that have come. I also have a couple of sample questions that I would like to discuss. So assuming this gets finished in another 1.5 hours, we will cover the sample questions that are asked at the exam. And all this content will be shared with you by the end of today, somewhere close to midnight, maybe, depending upon the tasks that I'll have to, go through. Okay, so after this practical, let's quickly come to Azure Face Analysis. For the certification, you should know what service is used for what operation. Okay, so if we talk about, let's say if someone talks about image classification, you should know that's a part of custom vision where one can classify images. If we look at object detection, one can detect objects using custom vision. However, you could be also using the pre-trained models from Azure itself, which we did yesterday. So that will be a part of computer vision. Moving on to face analysis. So Microsoft Azure provides cognitive services for face detection and analysis, including computer vision, video indexer, and face. So these are the 3 services that Azure provides to you for facial analysis. By a cognitive service, they are referring to a service that could be accessed via an API, where you could send an image or you could send a video, and Azure could do the analysis for you. Like, for example, if we upload this current video, Azure could tell us that someone was talking and some slides were being shared and information of that sort. So Face offers the most comprehensive facial analysis capabilities. So there are 3 options. You can use CV, you can use video indexer, and you can use Face. So Face is the most comprehensive facial analysis. So if you want to do facial analysis, Face is one of the best for you. It includes blur, exposure, glasses, head pose, noise, and occultation. So basically what they're trying to say is depending upon different lighting condition, different based upon how the image was clicked, how the video was recorded, if the person is wearing glasses or not, face is optimized to give you better results. Again, I cannot quantify it because that comes from use case to use case. So for certain people, it might give slightly better results. For certain people, it might not be the same. So This is again, all you need to do when you're using the face service is you need to upload the facial data and you need to create indexes. For example, let's say if we want to get the face service enrolled for all of us, let's say we start with Bahar. So we need 10 pictures of Bahar to be added. Then Gautam needs to be added. So we'll add 10 pictures of Gautam. Then we add 15 pictures of Mohammed and then maybe 10 pictures of Heer. And then we realize that, the analytics is not working fine for me. Maybe because I might not have so distinctive features. What Microsoft is searching for, I might add 15 or 20 pictures of myself. And if I feel that it is giving a higher confidence than the others, if it's overlapping, that it is recognizing everyone as my name, I could maybe reduce the value. But this is something that you get when you test, you build more, you understand what is the problem. I gave you an example what I faced in a real world example when I was using facial analysis. So I've used Azure for doing face recognition, but the most recent and the most popularly used face recognition in Azure is Azure Face. Additional capabilities like face comparison and named individual identification require submitting an intake form due to Microsoft's responsible AI standard. So if you want to do some analysis, like you want to compare faces, or you want to name the individual who is there in a picture, you have to submit additional documentation because Microsoft has responsible AI standard. So always remember, they will be asking questions around these things. So Microsoft's responsible AI standard, where is it? As I said, it's very, very important. Definitely asked. So when we look at the principles, this is what the standard talks about in detail. So these you can see, these are just 6 principles. So when you look at their AI standard, that is just about that how fair it is, if it's not discriminating, if they're not misleading your data, if they're not doing anything wrong with your data. That's why when we look at this, we can see that they have responsible AI. Since you're doing a comparison, since you're naming some individual, it can be critical, it could be used, it could be misused, and that's why you need to submit an additional form so that they get their compliance sorted. Going forward, the Azure Read API. And for the exam, you just need to know the names. Okay, so that's why I'm not going in a lot of detail. Just remember, Azure Faces one, service that you could be using for recognizing faces. Alternatively, you could have also used computer vision and video indexer, but face is the one that works best for faces. Computer vision is very generic. It has a lot of other functionalities as well. It is not as efficient for recognizing faces as when you use the face service. Moving on, Azure Read. The computer vision service on Azure can extract text from images using the Azure Read API. It can handle scanned documents, printed text, and handwriting. Results are organized into pages, lines, and words with uh, bounding box coordinate. So basically what's happening in the Read API, you can use this for OCR, that is optical character recognition. OCR is the name of the technology. Name of the services that you use is Azure Read API. So Azure Read is a service, Azure Read API is the API where you pass an image, it can scan it for you. If you've passed a document, for example, if something is written on this paper and I scan this and then I pass it, it can extract text and convert the handwriting or the printed text into digital text that can then be copy pasted or stored into a database and whatnot. The API works asynchronously. That means you upload and you do not need to wait. It's more of like, let's say if I have 100 files and it takes about a minute to read a file, though it doesn't, but let's say if it is something super complicated, something super large, you pass your data to the Read API. Uh, all you need to wait is for uploading. It is automatically going to process it. You can come back later and get your results back. You do not need to have a synchronous connection. You do not need to wait for it to respond. Does that make sense to all of you? Give me a thumbs up if that does. Asynchronous. The meaning of asynchronous clear to all of you? Okay. So the API works asynchronously using a 3-step process to submit an image, check on the status, and retrieve the results. So you submit it, and then you can check it again and again, again and again. What's the update? What's the update? What's the update? in the end, once you get the update, you would be good to go. The next in the series is the form recognizer. So the form recognizer service can digitize fields from recipients using OCR to extract key information such as the name and address of the merchant, date and time of the purchase, uh, quantity and price of each item, and total amounts. Provisioning a form recognizer resource can automate the process of extracting information from receipts. So one of the use case could be you could have a business which is getting, a lot of employee are submitting the claim request. Like, I had food, I took a taxi, I have booked a flight. They will submit all the requests, and you do not want to, have the manual intervention where someone is entering information. So you want to have a website, like a self-service website where people can go, they can upload the files, and those files can then be read, and the data could be added to the database. You can use something like a form recognizer, which is going to read the data, which is going to read the receipts, and that's going to add information to the database or whatever you want to do with that information. I'm so sorry, my throat is not on my side today. So Azure receipt analysis. So form recognizer in Azure offers intelligent form processing capabilities through pre-built and custom models that can extract data from forms, invoices, and receipts. So it can understand that this is the address, this is the person who sent the receipt, this is the amount, this is the item, this is the tax that's being charged. So you could be using this. The pre-built receipt model can recognize common receipts in English and extract key information such as time, date, transaction, merchant info, taxes paid, and receipt totals. Something which I just said. Users can create a form recognized resource or a cognitive service resource in the subscription to access the service. That's how you do it with every service. So this is a part of the cognitive services. So you get those services which come with the API, which are used for AI and ML, and then you could be using them. Moving on, we have we have text analytics. So text analytics is the process of using AI algorithms to evaluate various attributes of text, such as frequency analysis and sentiment analysis. Sentiment analysis is like, this seems to be happy, this seems to be sad, this seems to be neutral. How many of you have used Grammarly at some point of time for analyzing your emails before you send them? Quite a few. Even if everyone's not responding, I'm sure you might have at some point of time. So when you use something like Grammarly, which is doing the analysis for you, you're doing something called a sentiment analysis. Molly, go ahead. Okay, so I think you were just raising your hand for that. Okay, so basically what happens is when you have uh, text analytics, you can do something like frequency, like how frequently are you using a word, that shows that, what is the urgency or what is the text trying to say. And then you have sentiment analysis, which is like, this seems to be angry, this seems to be sad, this seems to be happy. So understanding what the user's mood is called as sentiment analysis. So Microsoft Azure's language cognitive service offers pre-trained models for language detection, sentiment analysis, key face extraction, and entity recognition, which can be applied to various applications. So for example, if someone is talking about a car, so text analytics can come back and say, hey, this person is talking about a car, this is what they meant. So if someone is sending huge emails to you for their complaints, and you do not want an entire team of people to read the emails and understand what they're saying, you could be passing them through text analytics, and it will tell you this is the summary, this is what the person is trying to say. So let's say if you're getting 100,000 emails every day, you want to rely on AI rather than relying on humans for doing the repetitive task of going through all the emails. You can use the text analytics service, which will then analyze what that text is trying to say, and will try to extract what the user is trying to say with what sentiment. Does this make sense to all of you? I know it is not super slow, but for the certification, you need to know just the key points. So receipt analysis for receipt, form recognizer for recognizing form, receipt analysis, part of the form recognizer, text analytics is analyzing what the text means. So, it's pretty straightforward stuff. Moving on, we have Azure Language Service. So the Azure Language Service can perform advanced natural language processing over raw text and offers two resources for use. So it gives you a language resource and it gives you a cognitive service resource. When you start a language service, this is what is created for you. The language detection capability identifies the language in which the text is written, while sentiment analysis can evaluate text and return the sentiment scores and labels for each sentence. So if you pass in a sentence, let me give an example. So the service could have been better. So that means that my sentiment is not happy, not satisfied. Or if someone says, I am amused by the service that you have offered, but I felt that the pricing was on the higher side. So over here, if they have to do the analysis, they'll be like, this is a positive tone, but then there is something negative as well. So I feel that this is 70% positive and this is 20% or 30% neutral. So that is the kind of data that you get with the language service. So we don't need to go in a lot of detail. Uh, this happens on a sentence by sentence basis or on a paragraph basis. So if you pass in a paragraph, it will tell you what the score for that paragraph is. If you pass in a sentence, it can be for a sentence. You can pass in an entire essay and then it can summarize the sentiment for you. Though this will make more sense if you pass your data in parts uh, for getting better result, because one paragraph might be happy, second might be sad, third might be neutral. It might just get you a very neutral score. So if you want the details, you might want to run the service on a para by para basis. So the key phrase extraction features can summarize the main talking points of a document by identifying the main phrases. So if someone has written, filler sentences that hope you are doing well, I wish you all the best, and with best regards, blah, 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 it summarizes stuff for you. So you might not want to use the service on an individual level, but for an organization that is getting hundreds and thousands of emails and is not having the time and opportunity to go through each one of them, they could be using something of this sort to reduce their workload, where things can be summarized. They could select, hey, this person is talking about this. Now let's do, what we can to fix the problem. Does that make sense for all of you? Let me give an example of a use case. For example, let's say we have an organization where people are giving us the feedback of the workshop. Let's say we have 100,000 people who are attending this. Or let's say if it's a Udemy course, we upload it on Udemy and hundreds and thousands of people review it. Now, I might not have the entire time to go to each and every comment, though I might want to, but I might not be able to. So I could process my data if there is an API. Obviously, there's not, it's not something which is so easily possible. But let's say if Udemy offered an API where I could extract all the comments and then I could ingest them inside Azure Language Service. Language Service will give me a summary that, okay, out of all the comments that you've got, 70% of the comments are on Azure. That means, 70 people are, 70% of the people are doing something to do with Azure. Then you could do sentiment analysis on Azure that, hey, uh, people are having so and so positive sentiment, people are having so and so negative sentiment. So someone, if they want to get a bird's eye view, they can get a very broad level idea that, okay, just by looking at this data, I can be sure that, this is what the people are feeling. If they're understanding things, if they're not understanding things, if they're liking it, if they're not liking it, that is the job that the language service can do. In the certification exam, you'll have a lot of question on language services. So do read this once, do read the slides once before you go for the certification, and you'll be at a good spot. Next is speech recognition and synthesis. So AI systems that support voice integration require both speech recognition and speech synthesis. So recognition and synthesis, recognizing is recognizing what someone is speaking and converting it into text. And synthesis is converting the text to speech. Now, let me give you a real quick example of this. Okay. I'm not using an Azure service, but let me just share my screen once again. I had to open the browser, so here you can see it. English to French. So let's say if I click on this icon.
Bonjour, bienvenue à l'atelier AI-900.
So this is basically speech synthesis. When we have text and an artificial intelligence converts that text into, into the sound that humans like, into speech basically. So when you have text to speech, you are.
Bonjour, bienvenue à l'atelier AI-900.
Yeah. So when you have text to speech, you are looking at the, let me come back. You are looking at speech synthesis. So recognition is when you speak something and they convert it into text, and synthesis is when something is written and it is converted into speech. So recognition involves converting spoken words into text data using model such as acoustic model and a language model. So acoustic is different people sound differently. So that is what the acoustic model does. And for the model to understand English, French, or Spanish, or any other language, a language model is used because they need to know what sound the person is making, how it is related, and what that word means. So that's what is a part of speech recognition. Recognized words can be used for various purposes, such as creating transcripts or providing captions. So someone, I think, in the Zoom call started by uh, turning on the create transcript feature. That means whatever I'm speaking will now be getting converted into a transcript, which will be shown as captions to all of you. So speech synthesis involves converting text into speech by assigning phonetic sounds to each word and synthesizing audio using a voice and other parameters. So A, B, C, like for example, A and D will sound like and, speech, SPEECH will sound like speech. So E is E, CH is ch, and then SPE is like sp. So this is what is, this is what is stored within the model. That if you read this word, this is what you have to, create a sound like. So the output of speech synthesis can be found by generating spoken responses, creating voice menus, and broadcasting announcements. So for example, when you call your helpline for, let's say, your service provider for anything, they'll be like, press 1 for this, press 2 for this, press 3 for this. In most of the cases, they are using computer generated voices for the commands, and that's why they are using they're using speech synthesis. Now, I've noticed this fairly recently with my banks. So when I call them, they say, please say out the last 4 digits of your credit card. So when I say that, that is using recognition. And when they respond back, hi, welcome, Javesh. I know no one would have recorded saying Javesh over there, right? So that means that that is coming in from synthesis. Does that make sense to all of you? Straightforward stuff. Recognition is when you speak and the computer understands. Synthesis is when the computer has something typed and it converts it into audio. Okay. Next is the Azure Speech Service. So Microsoft Azure offers speech recognition and speech synthesis capabilities through Speech Cognitive Service, which is speech to text and text to speech. To use this API, you must create a cognitive service resource. So basically what you're seeing is with a lot of AI, with a lot of ML, cognitive service will be discussed again and again. So these are the, this is the service that creates APIs for you, that manages the APIs for you. And multiple services are a part of cognitive service. So once you go revise through these slides, you will be able to read more about that. Moving on, the speech resource is suitable if you only plan to use the speech service, while the cognitive service resource is suitable if you plan to use speech service with other cognitive services. For example, if you want to use sentiment analysis, you want to use translation, you want to use, you want to store stuff to the database, you could be using the cognitive service, because then you could create a flow that whatever the user speaks, depending upon the inputs, please use a bot to respond, please answer that, please, store this in the database, or whatever you want to do with that information. Going forward, we are, okay, let me share my screen again. We are almost at the end of this, because again, as I said, for this certification, all you need to know is what each and every service is doing, which is very straightforward. So not a lot for me to explain in this. So speech to text API. So the speech to text API provided by Microsoft Azure can be used for real-time or batch transcription of audio into text format, and can be sourced from a microphone or audio file. So either you could be giving a live input from a microphone, or you could have an audio file, you could be uploading that. So it could be real time or it could be batch. Let me tell you the difference, because again, that could be an exam question. Real time is, for example, you upload the data, it does the processing, and you come back and it gives back the response to you. So it's an active API. You send the request, you get back a response. Batch is like, let's say you have 100 files, or you have 10 files, you have 20 files. You give it the address that, hey, these are my files, please upload it. So it is going to upload all your files on its server or on its service. It's going to do the processing, and then it's going to come back to you. So you can go back, after some time and say that, okay, can you have you converted all the speech to text? If so, please give me the text that you have, that you have discovered from the speech that was given as an input. So the major difference between real time and batch is real time is synchronous. You send the request, it does the processing, you give back the response. In batch, you have uploaded everything and you're waiting for it to process. You can go and access it all at once. So it uses a pre-built universal language model optimized for conversational and dictation scenarios, but custom models can also be created and trained. So for example, it has a ULM, that's a universal language module. But let's say if you have a different accent, let's say, I mean, this is again very hypothetical, but let's say there is a new language that comes up and you want support for that and Azure is not supporting it, you can build your own model by all means and do the speech to text API. So in that, how will you create the model? You will have multiple samples and then you'll tag them. And hey, this person is saying this person is saying this person is saying this, and then it will recognize. For example, I'll give you an example, like my name. Some people call it Jivesh, some people call it Jivash. The accent is different, right? Now, obviously, I am used to calling myself Jivesh because that's what I have heard while I was growing up. But I could not say that, certain languages have certain words that are silent, certain words that are given more emphasis on. So the sound is a little different. So if you want a use case where you might have people from different accents giving in the input and you want to support all of them, you could be training your own models. Again, how you do them is very detailed, not a part, but you have an option to do them in speech to text. Okay. Going on, real-time transcription requires audio streaming to the service and returns the transcribed text. For example, in Zoom, if you open CC, that's closed caption, while I speak, some text will be generated, and that is called as closed caption. So it is real time, right? You're sending it, it is, it is getting streamed and then it is giving you, it is getting streamed and it is then giving you the text in real time. And batch is when you have a recording, you upload it asynchronously. You do not wait for it to complete and you're good to go. Once it's done, you can go and get your results. Next is text-to-speech API. So the text-to-speech API allows for conversations of text input to audible speech, which can be played directly through a computer speaker or written to an audio file. So you can go to the text-to-speech API. You can be like, hey, this is my script for the event. Like you might have seen a lot of videos on YouTube these days. You have these scripts written, people pass them to text to speech API. This gets converted into audio, and this audio could be either a MP, MP3 file or any other file which you want, which is supported by the API, or you could be playing it in real time if you're using the UI. Does that make sense to all of you? Again, I'm not spending a lot of time on them because this is very straightforward. Growing up in the era where we have all used Google Translate, we've all seen ChatGPT at some point of time in our life, these concepts are very, very basic. So it's not something Azure specific, right? We have already seen text to speech. It's there on Google, it's there on other services as well. Speech to text, we've already seen it on other services as well. They have put the same thing on Azure. So straightforward stuff, nothing in detail, because for the certification, there is nothing Azure specific that you are supposed to know. All you need to know that they want you to know is that you know what is text to speech, you know what is speech to text. Speech to text is when they are recognizing what you are saying. And text to speech is when you have some text and you're giving an output as a speech. Now here you need to know that the output could be either in a file, they could save a file for you. By they, I mean the Azure API that we're talking about, or there could be another option where it's not doing it for you. You're just, you know, what would I say? It is generating some output on the real time. Going forward, you have literal and semantic translation. So automatic translation or machine learning translation is increasingly being used to remove language barriers in global collaboration. Literal translation presents issues due to difference in language and context. So understanding semantic context is necessary for accurate translations. Text translation is useful for documents, emails, and web pages, while speech translation is used for spoken languages through speech to speech or speech to text translations. Now, this is what is being used these days. This is where literal and semantic translation comes into play. While I'm speaking in English, someone is understanding the same thing in French, hypothetically. It is very, very critical to understand the context, because if AI does not understand the context, if it is not well trained, there might be quite a few issues. One of the most common issues being that one word means different things in the same language. So if it picks up the wrong context, it might be giving us information which is totally not what someone would be referring to. So it might be totally inaccurate. That is something which is very much possible. So we have to be extra careful for that. Otherwise, the entire purpose gets defeated. So if one word has different meanings in the same language, you want the words to be very clear. Plus, the problem with speech is different people speak differently, different pace, different tone, different accent. That's why these models, require a lot of training. Even after a lot of training, if you're using the caption service, you would see that the captions are not always correct. Not just for me, it could happen for anyone. So when you try to speak, unless you are very, very slow, the accuracy drops. Does that make sense to all of us? Give me a thumbs up if that's clear to all of you. Now, as a human, you might miss certain phrases I'm saying, certain words I'm saying, certain notes that I'm missing, but our brain is cognitive. It is able to, assume what the person might have said. So even if my audio starts breaking right now and it becomes like you hear and then it goes here and it goes and you hear and it goes, you'll still be able to understand most part of it because humans can understand. They have been, uh, they can assume that okay, this person might have been trying to say this word, and that's why, even if it gets dropped, you'll understand it. So there is a lot of work going around, literal and semantic translation. So you can get perfect speech to speech, but it is still not 100% possible. We are getting close with, the advancement coming in to AI. The next thing that we have is Azure Translator. So Microsoft Azure provides cognitive services for translation, including translator service for text to text, translation speech service for speech to text, and speech to speech translations. The translator service supports over 60 languages, while the speech services enables real-time closed captioning and two-way translation of spoken conversations. Now, this is the thing with AI 900, it's official documentation as well. The content is not fast. And that's why you'll see a lot of concepts being discussed again and again, again and again. This is the problem with the documentation as well. But since they have discussed them at different parts, this PPT is obviously inspired by that. So this is something which we've already discussed. So this is more of detail of what we discussed previously. So I'll just tell you from exam standpoint of view what you need to know. And then things will be kind of easy for all of us. Yes. So you see this page. If you understand this slide, you are already done with quite a few questions. So language is where you use the service to access features for understanding and analyzing text. What the user is trying to do, semantic, uh, basically understanding the mood of the user is something that is done in language. Translator is a text-based service for more than 60 languages. Speech can understand what the human is saying, and it can also synthesize at the same time. And next we have Azure Bot. So Bot is obviously a bot service where people can create chat bots that can talk to people. It could be, taking an input, giving an output, common questions answered, FAQs, making some bookings. Those are some use cases for the Azure Bot. So I'm saying this again and again. Remember the name of the services, and then the exam is super, super easy. It is nothing out of the ordinary. Coming back, Azure Translator. So Microsoft Azure provides cognitive services for translation, including the translator service for text to text translation and speech service for speech to text and speech to speech translations. The translator service supports over 60 languages, while the speech service enables real-time closed caption and two-way translation of spoken conversation. If I am speaking in English and let's say one of us, Bhargav, is speaking in French, so we need speech-to-speech translation. That translator cannot give us. Translator is a text to text, right? So if let's say Bhargav enters a text in French, it converts French in English in form of text, I can use the translator. But if I am using the translator to convert it into speech, so you know, we are using the translate API as well as we are using the speech API altogether. Does that make sense? Anything that has to do with text is text. Anything that has to do with speech comes in the speech API. So it's not difficult to understand. These are the questions that are asked over and over again. Both the services require appropriate resources to be provisioned in an Azure subscription and offer optional configurations for profanity filtering and selective translation. So you could customize these services. That's what they're trying to say here. Honestly, I've never used one of them, so I cannot say what is the customization, but that is something which is not required for the exam. So by now, I believe you guys would have understood with the number of services that a cloud service provider, so public cloud service provider offers to you, it is technically impossible for you to work on all of them. And I'm quite sure there would be very few people who could say that they could work on any service on Azure or any service on AWS. Even after spending years and years, the technology is so ever evolving that you cannot just gain master, you cannot master all of them. You can understand what each and every service is doing, and when asked to work upon it, you can go through the official service documentation and you can maybe work on that specific service. Going on, conversational language understanding. So CLU or conversational language understanding involves defining utterances, entities, and intents to train a language model to interpret user input and respond appropriately. This includes a required non-intent for handling unmatched utterances. For example, if now I'll talk more about this. This is a little interesting. So let's say when you are building a chatbot, you need to train your bot that this is the utterance. Utterance is the word. If the user says book a ticket, let's say I'm creating a bot for chat, for booking flights. So if someone uses the word book, if they use the word itinerary, if they use the word travel plan, these could be utterances. So you could be like, okay, if the user says book, if the user says itinerary, if the user says travel plan, in that case, they are trying to intent. The intent is to book. So intent is basically what the user is trying to mean. Because as I've said, multiple ways of saying the same thing, right? I want to book a flight. Please book a flight for me. Can I book travel? How can I travel from, let's say Montreal to New York? Things like that. The user's intention is to book. Does that make sense? So intent is what the intention of the user is, and utterance is what the user might say to mean that intent. So whenever you're training the model, you need to have these things clear in your mind. Utterance, what the user is saying, and intent, what the user means when they say that. Does this make sense? Give me a thumbs up if it does. Yeah. Not a lot of you. I'll repeat it once again. I'll be slow because this is important. Everything else, you can just go through the slide once and you'll understand. So when you have conversational language understanding, when someone needs to understand what the human is saying, what the human is trying to mean by what they're saying, they have two things: utterances, what they say; intent, what they mean. If I'm saying book a flight, please book a flight, I want to book a flight, book travel for me, book air travel for me, I am meaning that I want to book. So book is basically my intent, and whatever I'm saying to call that is my utterance. Does that make sense? Give me a thumbs up, guys. Come on. Okay. So when you are training a conversational AI model, it needs to understand what the user is saying. So you fix what is the utterance, you tell it what are the entities. Entities are like, we have flights, we have trains, we have buses, we have Air France, we have Air Canada, we have Air India, we have, let's say, Qatar Airways, we have American Airlines, or we have Delta, we have whatever, the list goes on and on. There's no end. So those are the entities. And then you try to, interpret what they are looking for. And then depending upon what they are looking for, you give them you give them a response, and then you can continue the conversation. So you need to define what could be the utterances, what could be the intent, and what are the entities that the user will be communicating against. So whenever you're training a model that has something to do with conversational language, remember utterances, what the user says; entities are like subjects, for example, flights, food, or any object that you have; and intent is what the user is trying to do to it. I want to order a burger. So I want to order a burger is basically the intention is to order. The utterance is I want to order a burger, exactly what I'm saying. And the entity is a burger, and to make an order. Going forward with this, so we have Azure Conversational Language Understanding. This uses natural language understanding. So conversational language understanding in Azure involves creating entities, intents, and utterances to train a language model for predicting user input. Authoring and prediction require separate resources with pre-built domains and a web-based interface for authoring. The model is trained through an interactive process and published for client application to use through a prediction resource endpoint. So this is the service. It's called Conversational Language Understanding. It's where the service tries to understand what the user is trying to put in by using the uh, entities, intent, and utterances. I'm saying this once again, it's not a part of the certification, but it is kind of important to understand what this is. Utterance is what the user might say, or what can be different ways of saying the same thing. Intent is what the intent is in respect to our application, and entity is what the user is actually referring to. Conversational AI refers to the use of AI solutions that make use of AI agents, commonly known as bots. So bots are basically, a chat bot or a bot that we talk to on call, which is like, say, your last four digits of your card. So that's again a bot. So they provide a first line of automated support through various communication channels, including chat, email, social media, and calls as well. So according to the documentation, they have not mentioned calls, but it is something used, so calls could be added to this list. These bots use natural language processing to understand questions and provide answers from a knowledge base. So you give a knowledge base like FAQs, you give it like if people ask you for booking, ask them their start date, their end date, their two-way trip, one-way trip, flight, budget, blah, blah, blah. So that is the base. According to that, it's going to ask you questions and it's going to continue the conversation. It could be a help bot, which you could go to if you want some help. Many websites have this, and you can just enter what the problem is. First line of support is provided by AI so that human intervention can be less. Uh, Let me give you an example. Today during the break, I got one of my orders delivered from Uber, and the contents of the order were incorrect. So I went to the chat into the help. I informed them that my contents are wrong. And then there was an AI talking to me. They gave me a very prompt support because no human was involved. AI processed the refund and I was good to go. If this would have been a human, I would have to wait for them to read, blah, 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 go through the entire process. And that's why many organizations are using conversational AI. So humans get a human-like feel, but in reality, no human is in the background. There are bots that are analyzing what you're trying to say, and depending upon that, they are performing actions. Uh, we have the Azure bot service. This is used to create a user support bot on Microsoft Azure. You can use the language service to create a knowledge base. So you can use language service where you can tell if user says this, this is the answer. If this is the question, this is the answer. This is the question, this is the answer. And then you can use the bot service to, so basically bot service uses the language service in background and gives you the option to use a chatbot. And then this could be integrated to social media, it could be integrated to Slack, it could be integrated to the other services that they have. So you could be using this along with your WhatsApp as well. So you'll see many organizations have WhatsApp business where the bot talks to you. That is where they're using a service such as Azure bot service in the background. An equivalent of this in AWS is called AWS Lex, and it uses, it's a chatbot. So you give it questions, it provides you with answers. Next is anomaly detection. So anomaly detection is basically, I'm so sorry. Okay. Anomaly detection is when something out of the ordinary occurs and it gives you a kind of a warning. And scenarios can include monitoring blood pressure, evaluating product failures. So if you have to detect if something is out of the ordinary, you can be using anomaly detection. Azure has its very own anomaly detector service. This service is a cloud-based service within the Azure Cognitive Services that can monitor time series data and detect anomalies without requiring a machine learning knowledge. It uses one parameter strategy with the main customizable parameter being sensitivity. So if you feel that if some data is coming in, if the sensitivity of the data is, let's say, anything above 120 is considered high, so you could be using this. And this service is used along with sensors and IoT devices. So it acts like a monitor. So whatever data the sensors are giving, you pass in the Azure anomaly detector. If it feels something is out of the ordinary, it could raise an alarm. For example, you could have a sea level monitoring sensor installed at some part of the seashore. And when the water level goes high, the IoT device is sending data to Azure. It is capturing the data. The moment it feels it has hit, beyond what is the normal, you can set your own sensitivity, and then it could raise an alert that, hey, now the water is actually very high. it is time that we actually, look into it and we look for a solution. So the working of this is the Azure Anomaly Detector service identifies anomalies using a boundary set by sensitive values calculated within the expected value, upper margin and lower margin. So basically, if I am getting 100 values for, let's say, 60, 65, 65, 70, 75, 70, 68, 62, 55. So the values will be between 55 to 65. That's normal. The moment I hit 90, that is an anomaly. So there's a lower margin, there's an upper margin, there's an average, and then you could be setting that. So you can have 8640 data points. Again, not important for the certification. You can leave that. So for streaming scenarios, the service compares current and previous values. So if you're getting a real-time data, let's say, you are getting real-time readings from what the sea level is, or you're getting real-time readings from, from the heat of your car. Let's say you have installed an IoT device on your machinery that is calculating how hot it is getting. If it is going above 700 degrees Celsius, you want to raise an alert. That is something which you could set in the anomaly detector, Azure anomaly detector. When it is working, the moment it feels that something is out of the ordinary, it is beyond the range, it can detect the, you know, it can detect and it can raise an alarm. Why is it used and where is it used? For example, if you could use it, you could, if let's say if you have smoke detectors in a building that are connected to the IoT and they're passing data to Azure, you could then, let's say whatever service they're passing the data to could be using anomaly detector in the background, which will then detect that, hey, if the smoke level is above 5%, I think that might be a concern. If the smoke level is above 10%, definitely a concern. Smoke level above 15%, call the fire brigade. If it is 25%, maybe do something else. So that is something where you use anomaly detector. It is like a passive monitor. You are not monitoring it. You are not doing it. No human is doing it actively. You have just set your rules and your rules are being monitored for the data that you have passed, you have streamed through it. If it feels something is out of the ordinary, it is going to, raise alerts. With that being said, we are, I think, on the last topic for this certification, almost at the end of it. That is Azure Cognitive Search. So Azure Cognitive Search is a highly available PaaS search engine that accepts data in JSON format from any source. So for example, it's a knowledge engine. You can ingest your data. For example, let's say you have, you know, sensors which are calculating the heat. You have, other data sources from where you're getting the temperature value. You have the data sources from where you're getting the humidity. There are other sources from where you're getting, information like which region is having which humidity. And basically, when you have a lot of data and you want to make searching easy across that data, that's where you use the cognitive search. So the data is given in as a JSON format. You can use any source. It could be an IoT device, it could be a server, it could be logs, it could be, something input by the user manually. And what happens is once the knowledge base has been created in this PaaS service, you can search through data. You can see when events were triggered. You can see what you passed in. A good use case of this service will be, let's say, we have a law firm and we have case files for the past 10 years. So we have entered information about every case into this service. And tomorrow, let's say we have a similar case and we want to know what was the course of action that we took and if that was nice or not, we could have a custom search engine. And that's what is cognitive search. For example, I mean, I do not want to say this, so do not take it very directly, but it is somewhat like a search engine such as Google, not Google, such as Google, which is working on your own data set. So, or you could compare it more to Bing, being a Microsoft product. So it's like a search engine, like such as Bing, searching on your own data. That's why it features full text search, AI-powered search, linguistic analysis for 56 languages, and geo-enabled search filtering. You can filter like, please give me the data for, you know, like let's say if I have an office in India, I have an office in UK, and I have an office in US, one in Canada. We can be like, please give us data to cases specific in Canada, because US is a different geography, UK is a different geography, and India is a different geography. So basically, this is the uh, feature that you get for filtering. This is more about the filter that it comes with. Going forward, Azure Cognitive Search also provides a configurable user experience with features such as autocomplete, auto-suggest, pagination, and hit highlight. So autocomplete, we all know, if I'm typing CA, it will suggest you can type R. It will suggest you can type T. It will suggest you can type, other words as well. That is autocomplete. Autocomplete will be basically, if I press tab, it automatically completes that. Auto suggest is where it is suggesting me what could be the possibilities. Pagination is when you have a search result for, let's say, 200 or 300 files. It does not show you everything at once. It will show you page one of two, so sorry, page one of five, page two of five, page three of five, four of five, five of five. So it splits the results for you for your search, and it gives you in form of different pages. And it hits, it highlights the hits that you have already made. So, if this is a commonly referred URL, it is going to highlight that for you. In simple words, if you've seen Google does it for you publicly. If you want to do it only for your data, if you use Bing, that's another public search engine, you want to only do it for your data, you could be using something like the cognitive search. It's like a very personalized, very privatized search with which is running against your data itself. Does that make sense? Give me a thumbs up if it does. I know we all are tired. Sunday afternoon, I do not want everyone to be sitting for long. That's why I'm trying to make it short and brief. And at the same time, I'm trying to complete everything that is required. Because the certification does not require a lot of details. So, not going into details, which are absolutely not going to be asked. Azure Cognitive Search AI enrichment skills. So the Azure Cognitive Search AI enrichment skills extract text and information from unstructured content using pre-trained models or custom skills. So for example, again, they will be using some extraction, machine learning extraction. So out of some text, which might be a JSON file, which might be, let's say, some other file containing some other information. So it can go through that and it can understand what is written in the unstructured data so that you can have better suggestion and better results. You have built-in skills include natural language processing skills such as key phrase extraction, image processing skills such as optical character recognition. Now, this is very interesting. I've lately seen this in multiple applications. Let's say if you have images that have some text written in them and you use the search, it can automatically recognize, it can show you the results as images which have that text written inside them. Does that make sense? So it's not just looking at the text that you have input, it can also look at the images that contain text. So for example, if I upload, where is that? I got a flyer yesterday for an example. Let's say this is a flyer from one of the restaurants. I try and upload this, on this search. And let's say if I want to search for duo dinner or something, whatever this thing is, and then it is going to go like, hey, I do not see any text for duo dinner, but I see that you have a duo dinner in this image, and that's what it can do for you. So if you have images, if you have unstructured data, if you have structured data, it could search across multiple verticals. It can use, natural language processing and even optical character recognition to give you better search results. Uh, Talking about the search indexes, in Azure Cognitive Search, an index is like a container of searchable documents where each document represents a row in the table and the fields in the documents are like column. The structure of the data in the documents is defined by the index schema and behaviors or attributes, which can be assigned to fields to specify how they can be searched and displayed. So it has information on how it is going to display the data, what is the data that is going to be displayed, what are the indexes on which the search is going to be performed. Again, this is not important for your exam, but it is a part of the documentation. I've never seen a question on the indexes specifically, too much beyond the scope, but yeah, you could just read through it once and I think that'll be good for now. It is important to set the necessary behaviors when designing an index, as forgetting to do so may require rebuilding the index to add those features. So you can set what are the features you're looking for. You can it is basically you customizing what is the kind of data that you want. Just in a bit. So coming to the last slide, Azure Cognitive Search Knowledge Store. So knowledge store is a persistent storage of enriched content generated from AI enrichment in a container. It can contain table, object, or file projections, and in a mutually exclusive output of the same pipeline as the index. It can be used for further analysis or processing. More of like it creates something persistent. For example, if it has found that this document contains, for example, I've uploaded this document contains information about bowl value or something, so it will tag it, it is going to store it, so that it is more of like, you could imagine this to be working like a cache. So if someone searches something again and again, it is not doing the analysis on the image again and again. It has created its own knowledge store, which has got the knowledge that is required for the processing. With that being said, we are officially done with all the content. Thank you so much to all of you for sticking around. I know, attending the event on weekends is not something super easy for all of you. Now we would be discussing a couple of questions, and I have a few things in the chat that I want to discuss. I'll just stop with the recording. For those of you watching this on YouTube, I hope this has been helpful for you. And if you have questions or if you want to be a part, look for the emails and join the event next week.